Ever wondered what would happen if you fell into a black hole? Would you, like a piece of spaghetti, stretch out to a thin strand? Welcome to the captivating world of astrophysics, where reality often sounds more like science fiction. Today, we're unraveling the mysteries of a fascinating concept known as spaghettiification. Yes, you heard it right. Spaghettiification isn't just a whimsical term. It's a serious phrase used in the realm of astrophysics. This term describes the vertical stretching and horizontal compression that objects experience when they fall into a black hole. Imagine a perfectly round object, like an apple, distorting and elongating as it's pulled into the infinite abyss of a black hole. It would stretch vertically into a long, thin strand while compressing horizontally, much like a piece of spaghetti. Sounds intriguing, doesn't it? But how does this happen? To understand, we need to dive into the world of black holes. Black holes, the cosmic vacuum cleaners, are notorious for their intense gravitational pull. They're like the universe's most mysterious yet fascinating enigmas. But what makes them so extraordinary? Let's delve into the intricacies of black holes and uncover some of their secrets. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape their grasp. They're born from the remnants of massive stars that explode in supernovae. Yet despite their end-of-life birth, they wield the power to distort the very fabric of space and time. This distortion creates a gravitational well so deep that the laws of physics as we know them start to twist and turn. Imagine throwing a pebble into a pond. The pebble disrupts the water's surface, creating ripples that spread outward. Now picture a black hole as an infinitely dense pebble. Its immense gravity disrupts space and time, creating ripples known as gravitational waves. These waves stretch and squeeze anything in their path, a concept known as gravitational lensing. But let's get to the heart of a black hole, the event horizon. It's like the edge of oblivion, the point of no return. Once you cross this boundary, there's no coming back. It's the point where the gravitational pull becomes so unbearably strong that escape is impossible. The event horizon is the gatekeeper to the black hole's singularity, a point of infinite density where our understanding of physics breaks down. So when something or someone crosses this event horizon, spaghettiification happens. But how? Imagine you're falling feet first into a black hole. What would happen to you? This might sound like a plot from a science fiction movie, but it's a real theoretical consequence of diving into the enigmatic black holes. This process is known as spaghettiification, a term that sounds amusing but describes a rather terrifying reality. It's all about the immense gravitational pull of a black hole. Let's break it down. Near a black hole, the force of gravity is so intense and varies so rapidly over short distances that it can stretch and distort objects significantly. Now, if you were to tumble into a black hole feet first, the gravitational force at your feet would be much stronger than at your head. This difference in forces is what scientists call tidal forces. These tidal forces would start to stretch you out vertically, elongating your body. At the same time, they would compress you laterally, squeezing you in from the sides. The end result? You'd begin to resemble a long, thin strand, much like a piece of spaghetti, hence the term spaghettiification. But don't think it ends just there. As you continue to fall, you would be stretched more and more, until you're just a thin stream of atoms spiraling into the black hole. This process is so violent that it would tear apart anything that falls into a black hole, from a speck of dust to a star. And what's even more fascinating is the fact that from the perspective of someone watching from a safe distance, you would appear to slow down as you approach the event horizon, the boundary of the black hole. You'd seem to hover there for a while, fading from view before disappearing entirely. So in essence, you'd be turned into a long, thin strand of spaghetti, a horrifying yet fascinating concept, isn't it? As daunting as it sounds, it's all part of the mind-boggling world of astrophysics, where reality often surpasses the wildest of imaginations. Now that we understand what spaghettiification is, what does it mean for us? Well, let's be clear. Spaghettiification is not something you'd want to experience firsthand. However, this terrifying concept has some fascinating implications for our understanding of the universe. Firstly, spaghettiification is purely theoretical. No one has ever been spaghettified and lived to tell the tale. This is because the process would be lethal long before an object, or a person for that matter, reached the point of being stretched into a thin strand. But just because we can't experience spaghettiification doesn't mean it's not important. In fact, it's quite the opposite. The idea of spaghettiification gives us a glimpse into the extreme environments of black holes. It helps us understand how matter behaves under the immense gravitational pull of these cosmic monsters. Spaghettiification also highlights the importance of tidal forces in astrophysics. These are the gravitational pulls that cause the tides on Earth. But in the context of a black hole, these forces can be powerful enough to stretch an object into a thin stream of particles. Moreover, the concept of spaghettiification brings us face to face with the bizarre and mind-bending reality of our universe. It shows us that the laws of physics, as we understand them, can be pushed to their limits and beyond in certain extreme environments. One day, the study of spaghettiification might even help us answer some of the biggest questions in physics. Questions about the nature of gravity, the behavior of matter under extreme conditions, and the very fabric of space-time itself. So, while spaghettiification might sound like something from a science fiction novel, it's actually a crucial part of our ongoing quest to understand the cosmos. It's a testament to the sheer strangeness and wonder of the universe we live in. Spaghettiification, while a terrifying concept, helps us understand the extreme environments of black holes. So next time you're cooking spaghetti, remember, you're not just making dinner, you're contemplating the mysteries of the universe. Spaghettiification is just one of the many wonders of astrophysics. It's a field where the mysteries of the cosmos unfold, where we wrestle with questions that have perplexed humanity for millennia. Often these questions lead us to phenomena that are as bizarre as they are fascinating, like spaghettiification. Astrophysics, at its core, is an exploration of the unknown. It's a journey through the cosmos, where we encounter celestial bodies, phenomena, and theories that push the boundaries of our understanding. It's where we grapple with the nature of space, time, matter, and energy, but it's also where we discover the beauty of the universe in all its vastness and complexity. Take spaghettiification, for example. It's a process so extreme, so violent, it seems to defy the laws of reality. Yet it's a fundamental part of our understanding of black holes. It's a testament to the power and unpredictability of the universe, but also to the capacity of human curiosity and ingenuity. Through the study of such phenomena, we gain a deeper understanding of our universe. We learn about the mechanisms that drive celestial bodies, about the forces that shape galaxies, about the origins and destinies of stars. We unravel the threads of the cosmic tapestry, revealing patterns and connections that were once hidden. And with each discovery, we push the boundaries of our knowledge a little further. We challenge our preconceptions, we test our theories, we refine our models, we delve deeper into the cosmos, driven by a thirst for understanding, a hunger for discovery. But astrophysics is not just about understanding the universe. It's about marveling at its beauty, at its grandeur, at its mystery. It's about standing on the shoulders of giants, looking out into the cosmos, and daring to ask, what if? So next time you eat spaghetti, remember, in another universe, you could be the spaghetti.